solve for x. And here we have the exponential expression, 25 raised to the negative x plus 1 is equal to 125. Now notice, x is trapped in the exponent. So we need to remove these exponentials in order to solve for x. So let's think about the number 25 and the number 125 to see if we can come up with a common exponential base. So 25. We know 25 is equal to 5 times 5, or 5 squared. Now, the number 125, we know that this is 5 times 5 times 5, or 5 cubed. So we have identified a common base. That common base is 5. So let's rewrite our given expression here. So again, we are starting with the expression 25 raised to the negative x plus 1 is equal to 125. Now, rewriting both of those numbers with a common base 5, we have 5 squared multiplied by negative x plus 1 is equal to 5 cubed. Now we can simplify this a tiny bit by taking this 2 and distributing it through to each term in that binomial, which leaves us with 5 raised to the negative 2x plus 2 is equal to 5 cubed. Beautiful! So now that our exponential expression has a base 5 on both sides, we are ready to apply the inverse property. So we are going to take the logarithm, base 5, of both sides of this equation. And this will remove the exponential, allowing us to solve for x. And let's give ourselves plenty of room here. So applying the log base 5 to both sides, we now have the logarithm base 5 of 5 raised to the minus 2x plus 2 is equal to the logarithm base 5 of 5 cubed. Now, since the logarithm base 5 is the inverse of the exponential base 5, they are going to undo the effects of each other on both sides of this equation, leaving us with minus 2x plus 2 is equal to 3. Beautiful! So this is a much more familiar algebraic expression, and we're ready to start solving for x. So to solve for x, we are going to start here by subtracting 2 from both sides of this equation. And so we can see 2 minus 2 cancels itself out to 0, leaving us with a minus 2x is equal to 1. And last but not least, to isolate x, we are going to divide both sides of this equation by negative 2. So negative 2 divided by negative 2 cancels itself out to 1, leaving us with a beautiful final answer of minus 1/2. Now, for fun, because math is fun, let's make sure that this is in fact the correct final answer by checking our work. So in order to check our work, we are going to substitute x equals negative 1/2 into the original expression. So what I'm going to do is use our simplified original expression to evaluate. So we are going to let x be equal to negative 1/2 and plug this in. So what we're asking ourselves is 5 raised to the negative 2 multiplied by a negative 1/2 plus 2. Is this really equal to 5 cubed? Let's find out. So the right-hand side is all set. We don't need to simplify that any further, but we sure can simplify the left-hand side. We can see here that we have 2 negatives that'll produce a positive, but we can also see 2 divided by 2 cancels itself out to 1. So the left-hand side can now be written as 5 raised to the 1 plus 2, which equals 5 cubed. Woohoo! So we have officially confirmed that yes, x equals -1/2 is in fact the beautiful final answer.